climate change is contributing to the increasing frequency and intensity of climate and weather extremes across many regions of the world. These extremes, such as floods, droughts, cyclones, and heat waves, have caused significant socioeconomic impacts. COMPAS is a European-funded project under the Horizon RI Cluster 4 program that aims to develop a harmonized framework for climate and impact attribution of compound and sequential extremes, a crucial initial step towards the deployment of a European operational service.
I think what really motivated me to start working on this project is the scientific challenge, and then also connected it with a large societal impact. I think it's a very ambitious project where we try to link both compound flooding, climate and impact attribution. And I'm very curious to see how we can integrate all those different concepts into a successful project. One is that most attribution studies so far really focused on univariate drivers, so either rainfall or temperature. We are really interested in how a flood is actually impacted by climate change, or a heat wave combined with dry conditions. So we did a combination of these different factors and what the role of climate change is there.
On a higher level, the project is having a lot of challenges. I think one that we keep seeing not only from the project but across this very evolving research field is that there is a clear lack of guideline and guidance on how to attribute what we call complex extremes. So that could be compound events, a sequence of extreme events, or an event where multiple drivers are interacting. That's a real problem.
On the practical side, I think there's also big challenges related to uncertainty, because we're modeling complex compound extremes such as compound flooding and the tropical cyclones, heat waves and droughts, or wind and flooding due to winter storms. And apart from the uncertainty in the atmospheric signal, there's also much uncertainty in available data to construct our models. And this varies very strongly per area of interest.
The COMPAS project is actually providing guidelines, both on the data, the methods, but also possible workflows on how to do impact attribution. And this is really an effort through different expertise that's available in the consortium.
For example, in COMPAS, we're working on developing an innovative modeling framework for compound flooding. In that framework, we're combining models for river hydrology, for coastal surge, and for flood modeling, in order to obtain a more accurate picture of the compound flood hazard and tropical cyclones. But important to mention that in the spirit of open science, we also really try to make our work reproducible and share it openly so that other researchers in the field can benefit from it.
There are a huge range of different methodologies being developed across the COMPAS project, but the one I'm probably most passionate about and the one that I'm working on is around weather typologies. So looking at how we look at the large-scale drivers of our weather across the North Atlantic, the UK and European region, and how that links through into the compound events and eventually climate attribution. I think the key thing here for the legacy of the project is developing a methodology that can be translated into different regions across the world.
It's really important to us to engage with local stakeholders, because we can bring a lot of data to different kind of questions in these contexts. But often local stakeholders have lived through extreme events, they've lived through disasters, they understand the local context really well, and they understand what's important, both in terms of what's happened, but also they have important perspectives on how things should change into the future.
One of the key long-term impacts of COMPAS is improving our understanding of how climate change influences complex extreme events. By moving beyond the study of single cases and examining how different factors interact and amplify each other, the project offers a more comprehensive view of those events. This deeper insight is essential for accurately assessing risk and developing effective strategies for mitigation. A major focus on COMPAS is making climate attribution an operational part of the Copernicus climate change services. Additionally, COMPAS promotes open science and collaboration by providing free access to data, methods, and tools, and involving local stakeholders in shaping impact pathways. The project fosters a cooperative environment.